Questions on the homework? Okay. What we're looking at today is simplifying rational expressions, and we will do a little bit with multiplication. A rational expression is a fraction whose numerator and denominator are non-zero polynomial expressions. So we could say x plus 3 over x plus 4 is a rational expression. The domain of the rational expression excludes all values that make the denominator 0. So we're talking about the x values, the values of x. So the values of x can be any number except whatever's going to make the denominator be 0. So in this case, it could be any number except what's going to make x plus 4 be 0. So here, x cannot be negative 4. Because if x is negative 4, our 4 plus negative 4 would be 0. Because we could plug it in here. Negative 4 minus 3 over our negative 4 plus 4. Well, the numerator, negative 4 minus 3 would be negative 7. Negative 4 plus 4 would be 0. We cannot divide negative 7 by 0, so it does not work. So any value that would make the denominator be 0 does not work. And an irrational expression is in simplified form when the numerator and denominator have no common factors. There's nothing in common on top and bottom. We're going to reduce it out. Questions on this so far? Okay. Simplifying rational expressions, this is the first thing we're looking at. So this is the property, and we have some examples. So the property says if A over A times C over B times C, since they have the C term in common, we would cancel it out, leaving us with A over B. Our numeral example, 15 over 65. Well, 15 is 3 times 5. 65 is 13 times 5. Since they have a common factor of 5 on top and bottom, we would reduce it out, leaving 3 over 13. In the other one, we have a common factor of x plus 3 on top and bottom. We would cancel it out, leaving us with 4 over x plus 3 as a simplified form. So we're going to look at this first one here. So we have 4 over x times x plus 2. As I throw markers on the floor. Is there something in common on top and bottom? No. It looks like the 4 and 2 would be in common. But here, the 2 and the x, since they're being added together, are a single expression. So we can't just simplify the 4 and 2 out. So incidentally, this is already in simplified form. It is simplified as it gets. It's as simplified as it gets. All right. So we really can't do anything with this one here. This one here is the first one we're going to really look at that can simplify. So we have 2 times x plus 1 over x plus 1 times x plus 3. Is there something in common on top and bottom? X plus 1, we have an x plus 1 in common. It will be. Now, one way that we can see this is I want to refer back to multiplication. Because we multiply two fractions, a over b times c over d. Well, it's the same as saying ac times bd. But we can also go the other direction. We can split this apart. Now, we're not going to have to do this every single time, but it will help us see how simplifying these does work with multiplication. Because our numerator, we can split it apart with our 2 and x plus 1. The denominator, we'll move our x plus 1 over here, so we do have what's in common together. And we'll have our x plus 3 with our other term. So we'll still have our 2 over x plus 3. However, what is x plus 1 over x plus 1, really? Unfortunately, it's not 0. What is anything divided by itself? 1. Anything divided by itself is 1. So we're really saying here, because x plus 1 over x plus 1 is 1. So we're just saying 2 over x plus 3 times 1, which is just 2 over x plus 3. So when we cancel it out or cross it out, this is what we're doing. We're just simplifying that term out. Because our x plus 1 over x plus 1 cancels each other out, leaving us with 2 over x plus 3. Because here, those cancel. Because we can only do this with multiplication on top and bottom. We have multiplication in the numerator and denominator, we can cancel it out. And we get this here. Questions on this so far? Now, I do want to talk about restrictions, because again, our restrictions tell us that whatever's in the denominator, especially what we start with, cannot be 0. Because if x plus 1 is 0, we'll have a division of 0, and we cannot have that. The same is true with our x plus 3. It cannot be 0. And an easy way for us to determine what would make those two be 0 as well, we set them equal to 0 and solve. So for our x plus 1, we can, from both sides, telling us x cannot be -1. For our other one, we would subtract 3 from both sides, telling us x cannot be -3. Because if we have an x value of -3 or -1, it would cause the denominator to be 0. Because again, x in this case is just an unknown quantity. So x can be any number, but if it's -1 or -3, it would cause the denominator of this to be 0, and we cannot have that. Questions on this here? Okay. Let's look at our next one here. Here we have x squared minus 4x minus 12 over x squared minus 4. Now here we don't have multiple things, or 2 or more things being multiplied together in the numerator or denominator. So what we have to do with these here is factor them down. Now the numerator and denominator will factor. And the reason we know they will factor is because of the x squared, the degree of 2. X squared minus 4 is one that's kind of nice to work with because we do have 2 terms being subtracted. X squared and 4 are actually both perfect squares. So what we have here is a difference of perfect squares. And since x squared minus 4 is a difference of perfect squares, our signs are opposite. One's going to be positive, one's negative. What are our factors of x squared? X and x. Our factors of 4 are 2 and 2. Because 2 squared gives us 4, x squared gives us x squared. Our x squared minus 4 is our x plus 2 times x minus 2. Questions on this so far? Now the reason we're doing this is to find out what's in common on top and bottom. Now the next thing we need to factor is our x squared minus 4x plus 12. It is. So our signs for 12, since the 12 is negative, our third term is negative, our signs are opposite. Factors of x squared are x and x. Yeah, so there is not a greatest common factor that we can pull out. So we can move on to our 2 sets of parentheses. Now at this point, our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now what's nice about these here is that the denominator is actually giving us a hint. Because if this does simplify, we need something in common on top and bottom. Which means one of the top 2 parentheses either needs to be x plus 2 or x minus 2. Because if we don't have that, nothing simplifies. Which tells me that, say, 3 and 4, if those were the factors for this here, nothing would simplify. It doesn't match with what's on bottom. So what would be nice to have, or which set of factors would actually help us? 2 and 6. Because if the 2 is with the plus, we do have an x plus 2 in common. If the 2 is with our minus, we'd have x minus 2 in common. Now, where do we want to put the 2 and where do we want to put the 6? Okay. And just like with our factoring, we can check this here. X times negative 6 is negative 6x. 2 times x would be plus 2x. And negative 6x plus 2x is negative 4x. Is that the middle term we wanted? Yes. Okay. Now, since we have both of these factors, now we can simplify on top and bottom because of the properties of multiplication. Is there something in common on top and bottom? X plus 2. So one of the x plus 2's, well, the only x plus 2 on top and bottom would cancel, leaving us with x minus 6 over x minus 2. And that's it. Questions on this here? Now we can look at restrictions on what's going to make the two denominators be 0. Even though x plus 2 did cancel out, we still want to list it. It's restriction, as well as x minus 2. Well, with our x plus 2 equal to 0, we're solving for x. And the first step in solving for x is going to be to subtract 2. Minus x is 2. So for x plus 2, what value of x will make it be 0 is negative 2. And again, we cannot have this be 0, so we're saying x cannot be negative 2. Here we can add 2 to both sides, telling us that what value of x is going to make x minus 2 be 0? Well, that'd be positive 2. So x cannot be positive 2. So for us here, x cannot be positive or negative 2. If we're listing the restrictions. Questions on this here? Let's look at the next one. We have x squared minus x minus 12 and x squared minus 9. Which one of these two do we want to factor first? Top one. The signs for this one here would be positive, negative, opposite. Since the third term is negative, our signs are opposite. Now we need the factors of the first and third term. Factors of x squared are x and x. Now our factors are 12. 1 and 12, 2 and 6, 3 and 4, 3 and 4. And we can check this here. X times negative 4 is negative 4x. 3 times x is plus 3x. Negative 4x plus 3x is negative 1x, negative x. So we get this here. Now we're going to factor the denominator. Well, our denominator is x squared minus 9. Well, we don't have a middle term, do we? No. Well, it will come out to 0. Now, x squared is a perfect square, yes? It's x and x. Is 9 a perfect square? 3 and 3. So we would have x and x. So it works out x squared minus 9 is actually a difference of perfect squares. Any questions on how we simplified this here? What's in common on top and bottom? So our x plus 3 over x plus 3 would cancel, leaving us with x minus 4 over x minus 3. Now, let's go on and list the restrictions. X plus 3 is equal to 0. If it does ask for it, yes. If it doesn't, you don't have to do it. So one of the restrictions For this here, it would be negative 3, because our x plus 3, negative 3 plus 3 would be 0. X minus 3, we would add 3 to both sides, telling us x cannot be 3. So x cannot be negative 3 or 3. Yeah. Because we could also say plus or minus 3, because we're talking about positive or negative of the same number. All right, let's look at the next one. X plus 4 over x squared minus 16. So if we look at the numerator, x plus 4, is it factorable? The degree is 1, and we know the degree because it's the biggest exponent is 1. There's no greatest common factor, so it is just x plus 4. X squared minus 16. So here we can factor with 2 sets of parentheses since there is no greatest common factor. And since it's a difference of perfect squares, we'd have x plus 4 and x minus 4. Partially, yes. Since it's a difference of perfect squares, we have x plus 4 of x minus 4. Factors that way. Now, what is in common on top and bottom? The x plus 4 and x plus 4, yes? Now we still have a fraction because x minus 4 is left in the denominator, the bottom. We would put 1. Because when anything simplifies out completely, it reduces to 1. Because really, if we did it the way we did the first one, we're saying that we have x plus 4 over x plus 4 times, well, the other denominator would be x minus 4, and the numerator would be 1. Our x plus 4 over x plus 4 would reduce to 1, telling us that we just have 1 over x minus 4. So if this had just been x minus 16, yeah, because there is no way to simplify it. All right, let's go ahead and look at the restrictions. Because our two denominators are x plus 4, x minus 4. Well, plus 4, we would subtract the 4, minus x would be negative 4, which means it won't work. For the other one, we can add 4. Minus x cannot be 4, because if x is 4 or negative 4, it would cause the denominator to be 0, and it would not work. Questions on this here? We ready for the next one? So this one here, we don't have a difference of perfect squares on top or bottom. So at that point, we just need to pick which one we want to factor first. Top. So our x squared minus 2x minus 3. So what would our signs be? Opposite, because the third term is negative. Factors of our first term, x and x. Factors of our third term, 1 and 3. Where do we want to put the 1 and where do we want to put the 3? Doesn't matter. Because again, we can check and make sure we have it set up correctly. X times negative 3 would be negative 3x. 1 times x would be plus x. And negative 3x plus x is, so that's the middle term we wanted. And again, when factoring or doing any of these here, especially with simplifying, because we'll do some with our multiplication, pick whichever one you can find the factors of easiest. Or you can see or kind of want to work with more than the others. Because once we have this, we know that if it's going to simplify, either one of the two parentheses is either going to be x plus 1 or x minus 3. Because if it's not, then we don't have anything that simplifies. Now, if we look at the denominator, x squared minus x minus 6, well, our signs would be opposite. Factors of x squared are x and x. Factors of 6 are 1 and 6 or 2 and 3. Which set of factors do we want to use? We can use 2 and 3. Now, if we use 2 and 3 for something to simplify, the 3 has to be negative, because if the 3 was with the plus, we wouldn't have anything in common. Now, we can check and make sure this does work. X times negative 3 would be negative 3x. 2 times x would be plus 2x, and negative 3x plus 2x is negative x. Is that the middle term we wanted? Yes. Do we have something in common on top and bottom? X minus 3 and x minus 3. So what that leaves us with is x plus 1 over x plus 2. Well, we can see. Simplify the expression if possible. Nope. And the product. Nope. None of them do ask for the restriction.
What about next one?
I mean, it's good to list the restrictions.
I just don't want to forget it.
Yeah, because it becomes very helpful when solving. Because if one of the restrictions shows up as a solution, it's defined as the extraneous solution. It's a solution that we get from solving but does not work in the original problem. Now our x plus 2, we would subtract 2, telling us x cannot be negative 2. For the other one, we can add 3, telling us x cannot be 3. Now some books will actually only list 3 as a restriction, and that's mainly because the negative 2 comes from our x plus 2. Since it's still contained in our answer, they don't list it because they most likely believe from the problem itself we can see that that is still a restriction. We list the 3 out because the term that gave us that restriction simplified out. So we still need to list it to know that it is still a restriction even though it's not here. Questions on this here? Multiplication with rational expressions. So if we multiply straight across and then simplify. So I still think this is an odd way to do it. Because kind of as they're saying with these here, and you can watch this here first, and then we'll do, actually I'm not even worried about it. Let's actually work this out. So if we multiply two rational expressions, here 8x cubed y over 2x y squared times 7x to the fourth y to the third over 4y, we can multiply the numbers first, going straight across. We're going to multiply these here. So our 8 times 7 is 56. The next thing we can multiply are our variables. So x to the third times x to the fourth. Because when we multiply like bases, we add the exponents. So x to the fourth times x to the third, 4 plus 3 is 7, giving us x to the seventh. Now our y times y to the third would be y to the fourth. Because y to the first times y to the third, 1 plus 3 is 4. Our denominators will do the same thing. So 2 times 4 is 8. Here are x. We don't have any x terms in the other one. It would just be x to the first or just x. Now we do have y squared times y, which would be y to the third. Yep, cubed, third, both work, because 2 plus 1 is 3. Now at this point here, we can do some simplifying, because 56 over 8, 56 and 8 do have like terms, yes? What would they reduce to? Reduces to 7. 7 over 1. Since there wasn't a denominator listed, it's understood to be in the numerator. X to the 7th over x. Whenever we have like bases when we're dividing, we don't add, we subtract. 7 minus 1 is 6. If it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. Well, where was it bigger on? Top. So it'd be x to the 6th on top in the numerator. Y to the 4th over y to the 3rd. 4 minus 3 is? So y on top or bottom? Top. Once it was bigger on top, stays on top. So our final answer is 7x to the 6 y. We could put it over 1, but it's still the same as this here, because everything in the denominator reduced out completely, leaving us with 7x to the 6y. Now we can still have restrictions for this here, because our variables in the numerator were x and y, yes? What value of x do you think would make the x's in the denominator be 0? It's as obvious as you might. So it wouldn't be 7, it would just be, because there is no number added or subtracted, so we can just plug in 0, because they're all being multiplied together, so x cannot be 0. What can y not be? Yeah. Because the only reason we had a different number on the others is because we had x plus 3. We had something added to it, something subtracted from it. Because here, all we're saying is that 2 times x times y squared cannot be 0. Because if x is 0, the whole thing becomes 0. If y is 0, the whole thing becomes 0. Questions on this here? Find the product. Well, we can do restrictions pretty easily. What can x not be? What can y not be? Yeah. Here, we can multiply our numbers first. 6 times 9 is? 6 times, well, then we can do our x squared times x to the 5th. Is x to the 7th, because our 2 plus 5 gives us 7. Y times y squared would be y to the 3rd, because our 1 plus 2 gives us 3. Now the denominator, our 3 times 2 is? Only have one x located in our two denominators that are being multiplied together, which just gives us x. Now we have y to the 3rd times y, which would be y to the 4th. Now the first thing we can simplify is 54 over 6. Well, we did 2 times 3, which gave us. Now we have x to the 7th over x. Like bases, we subtract the exponent, so 7 minus 1 is? Is it bigger on top or bottom? Top. So we'd have x to the 6 on top. The next one we have is y to the 3rd and y to the 4th, yes? 4 minus 3. Is it bigger on top or bottom? Bottom, so our y to the 1st are just y. Stays on bottom. Questions on this here? Let's do one more of these here. So we can multiply these together, because we can do 3 times 6, which is 18. X to the 5th times x. would be x to the
Oh, forgot where I am.
sixth. Y squared times y squared. Y to the fourth. The denominator, 8 times 9, 72. Our x times x cubed would be x to the fourth. And y times y is y squared. Now the nice thing at this point, again, with our numbers, the calculator can do those. It can't do the variables because it needs a value for them. But we can say 18 over 72 is 1 over 4. So we would have 4 in the denominator. Now we can put the 1 in the numerator, but I normally wait because if there is something left in the numerator, we don't have to list the 1 because 1 times anything else is whatever the other thing is. Let's look at our variables. X to the 6 over x to the 4th. 6 minus 4. Bigger on top or bottom? Top. So since we do have another term in the numerator, we don't have to list that 1 because 1 times x squared is the same as just saying x squared. Let's look at the y's. Y to the 4th over y squared. 4 minus 2. It would be y squared. Would we put it on top or bottom? We can put it on top because it's bigger on top. Because 1 times x squared y squared is the same as just saying x squared y squared. So we don't have to list it. You can. Yeah, we don't have to, but you can. So we get x squared y squared over 4. Questions on this here? See how we're doing on time. We will start with this one here tomorrow. So there's not much more to this. We're here because all we would need to do is factor and then multiply and simplify if possible. Now, we do have a few more things to look at, but 4 through 7 on the assignment is the simplifying that we've been doing. Just 4 through 7, and actually, let me look back at that. And then 12 is one that we just did today. So you can go on and circle all of them out if you want. But 4 through 7 and 12, you should be able to do now. So if you want to get started on it, you can. 7 or 132, it's 128.